Not everything you do is going to be an equation. You could be faced with an inequality. An inequality means it's not equal. In is the prefix for not, and equality is equal, and so it's not equal. In this case, absolute value of x is greater than 5. So what we're looking for is a value whose distance from 0 is more than 5. As we can see, the values of -5 and 5 are both 5 units from 0. Both of them have an absolute value of 5. So if we want an absolute value greater than 5, then we're going to want numbers further from 0. So we're going to want numbers that are less than -5 or greater than +5. Your book would have you just remember, when the absolute value of a number is greater than a value, then your answer is going to be in the form of x is less than -a or x is greater than +a. I can never remember that though. I always have to graph it first to see what it looks like, and then I can realize, oh, x is less than -5 or x is greater than +5. But that's just me. So you can either remember that that's always the form it's going to take, or you can graph it and see what it comes up to. But before you can graph it, we need to know how to solve the inequalities. And in fact, you already know how to solve the inequalities because they're solved essentially exactly the same as equalities. When we had the absolute value of x equals 5, we said that x equals -5 or +5. We had to account for both possibilities. When we have absolute value of x is greater than 5 instead of equal to 5, we still have to account for both the negative and the positive, but we also have to deal with the signs. For the positive value, the sign is the same. For the negative value, the sign is reversed. If you remember your inequality work from before, then that should have already been apparent. Anytime we do multiplying or dividing by a negative, we switch the sign, and when we do absolute value set to a negative, we switch the sign again. Everything else remains the same. If we turned that equation from before into an inequality, we're still going to solve it all exactly the same as we did before. Subtract the 7, multiply by 2, divide by 5, split into two functions, one for the negative and one for the positive, but in this case, since it's an inequality, we need to remember to switch the sign for the negative value. Then we continue to solve. Now again, the book would have you remember that when the original inequality is less than, your answer will be in the form of -a is less than x, which is less than a. Again, I can never remember that though, so I would need to graph it first to see what it looks like, and then I would recognize, oh, -7 is less than x, which is less than 1. But that's just me. Notice when I graph, I don't have a whole bunch of little tick marks for all the other numbers. I don't even show you where 0 is. I already know where all those numbers are. I assume you already know where all those numbers are. We don't need to make a mess of our graphs by showing where all the numbers in infinity are. All we need are the two values that matter for our particular graph. Also, notice that I put my lines up above. If you put it right on the line itself, it just gets lost in the line. We can't see it. Just put it up here at the top of the tick marks, and then it's easy to identify. Just like for the equation, we had to watch out for negative values. Same is true with inequalities. If this were an inequality and we were going to divide by -2, we need to remember that dividing by a negative changes the sign. Multiplying or dividing by a negative changes the direction of the sign. And then when we get it into this form, then we can look at it and we can remember when the absolute value is isolated and the other side is negative, we have a no solution situation. right? Because the absolute value will never equal negative 6, and it will certainly never be less than negative 6, because absolute value is always positive. There is, however, an exception to this rule. It's a tricky exception. If we had the absolute value of x is greater than negative 2, we might look at that and say, well, absolute value is always positive, which is true. But that doesn't have anything, that doesn't restrict us here. Because if the absolute value is greater than negative 2, then we have to consider for a moment, well, absolute value is always positive. And all positive numbers, no matter how small they may be, are always going to be greater than any negative number. So, if absolute value is always positive, and all positive numbers are greater than any negative number, then any absolute value will always be greater than negative 2. So this is kind of a trick question. Absolute value will never equal negative 2, but it will always be greater than negative 2. No matter what number you put in for x, the absolute value of that number is going to be positive and will therefore be greater than negative 2. So the answer in this case would be all real numbers. It's a tricky question, I know that. So let's kind of put it all together here. So if I have the equation negative 5 times the absolute value of 2x plus 1 divided by negative 3, all divided by 4, minus 6, is greater than or equal to negative 11, I don't have to freak out. I can take it one step at a time. First thing I need to do is get rid of that addition or subtraction with the negative 6, because we're going backwards on the order of operation. Then I multiply by 4, divide by negative 5, remembering to switch my sign when I multiply or divide by a negative. Now that I have my absolute value part of the inequality isolated, I can make the decision, do I continue? Up to this point, it's always been negative over here on the right side of the inequality. But now that it's isolated, I have a positive value over there, so I can continue. This is not a no solution situation. Now, before we've been working these, and I've always set it equal to two different inequalities, one positive and one negative. The book has another method that we can use here. Instead of doing two inequalities, one to a positive and one to a negative, the book has this other method where it puts the negative on the left and then uses the same sign. Now, it might seem strange. Well, I thought negatives were supposed to flip the sign. But in actuality, it is being flipped, because we always read from the variable out. So now if we read from the variable out, we get x greater than negative 4, even though it's written left to right as a less than. When we read it from the variable out, it is being switched. So it's kind of a trick on the I right there when we write it that way. But when we have it written this way, all we have to do is whatever we do to all the sides at the same time. So we're going to multiply every side by negative 3, which we have to remember is going to change the direction of our signs, because we're multiplying by a negative. Then we subtract off the 1, divide by the 2, and we should really turn any improper fractions into mixed numerals, because mixed numerals, their values mean more to us than the improper fractions do. 11 halves doesn't mean much to you. 5 1/2, though, should mean quite a bit. Now again, I can never remember how I should write my answer looking at the signs. I always have to graph it first. So it is equal to both the negative 6 halves and the 5 1/2. It is greater than the negative 6 1/2, and reading from the variable out, it's less than the 5 1/2. So then we have the lines going toward each other, giving us our solution to be written like this. Which is another reason that I really don't bother trying to remember things, because if we tried to remember the way the book says it, that would the greater than sign says it should have been something is less than x or something is greater than x. But because of all the negatives flipping the signs around, that gets thrown right out the window. So I continue to just graph it first and then see what the graph ends up looking like. That's my personal preference. And that is absolute value. So to summarize, absolute value is the distance from 0. Therefore, since it's distance, it is always positive. To solve an absolute value equation, make sure you do it for the positive and the negative value, because both can exist inside the absolute value sign itself. Make sure you don't change the way the quantity inside the absolute value sign is written. Keep that the same and just change the number on the right hand side of the equal sign. To solve inequalities, you do them the same way. Just remember to switch the sign for the negative value. Thank you very much.